A car can stop at a gas station when it runs out of fuel. An aircraft can land at an airport when it needs more fuel. A surface ship can return to port, connect fuel hoses, and refuel like many other large vehicles. But for a military submarine, everything is much more complicated. Because most of the time, it does not operate on the surface. It dives beneath the ocean. It hides in darkness. It moves through an environment where humans cannot naturally survive. There are no roads around it, no signs, no fuel stations, no place to stop in the deep sea. So where does a military submarine get its power from? How does it refuel? And how can a massive machine stay underwater for a long time while still maintaining electricity, water, propulsion, and life for the entire crew? To understand this, we first need to know that not all submarines use the same kind of power. Some submarines use diesel fuel and electricity. Some submarines use nuclear power. These two types operate in very different ways. And because of that, the way they refuel is also very different. For a diesel-electric submarine, the main fuel is diesel. This type of submarine uses diesel engines to run generators. The electricity produced by those generators is stored inside large battery banks. When the submarine dives and needs to move quietly, it often uses electricity from the batteries to power electric motors, which turn the propulsion shaft and propeller. A nuclear-powered submarine works differently. Its energy comes from a nuclear reactor. The reactor does not push the submarine forward directly. It produces heat. That heat is used to make steam. The steam spins turbines. And from there, energy is produced for the electrical system, the propulsion system, and many other systems inside the submarine. From the outside, a submarine looks like a long, silent steel shape. But inside, it is a closed energy system. It has fuel storage. It has batteries. It has generators. It has electric motors. It has pipes. It has valves. It has air systems. It has water systems. It has life support areas. It has storage for supplies. And all of these systems must work together with precision. If one important part fails, the submarine cannot continue operating for long beneath the sea. A submarine does not only need fuel to move. It needs power to operate equipment. It needs electricity for sensors. It needs electricity for control systems. It needs clean air for the crew. It needs usable water. It needs food. It needs spare parts. And it needs the ability to sustain itself in an environment that is almost completely separated from the outside world. Let us begin with the diesel-electric submarine. In this type of submarine, diesel fuel is stored inside fuel compartments within the hull. When the submarine needs to produce electricity, the fuel is sent through pipes to the diesel engine. The engine starts running and produces mechanical motion. That mechanical motion drives a generator. The generator produces electricity. The electricity flows into large battery banks. These batteries act as stored energy for the submarine when it is submerged. When the submarine is underwater and needs to move more quietly, the diesel engine can be shut down. At that point, the batteries supply power to the electric motor. The electric motor turns the propulsion shaft. The shaft turns the propeller, and the submarine continues moving through the deep sea. In simple terms, the energy path of a diesel-electric submarine works like this. Fuel goes into the engine. The engine drives the generator. The generator creates electricity. Electricity charges the batteries. The batteries power the electric motor. And the motor moves the submarine. That is why this type of submarine is not simply a fuel-powered vessel. It is a system that combines diesel fuel and electric power. Diesel fuel helps create electricity. Electricity helps the submarine dive and move more quietly. When running on electric power, the submarine can reduce much of the noise produced by engines. That is extremely important for a military submarine, because underwater, sound can travel very far. The quieter a submarine is, the harder it is to detect. So the batteries are not only a source of stored energy, they are also part of the submarine's ability to hide. But a diesel engine has one very important requirement. It needs air. More specifically, it needs oxygen for the fuel to burn. On land, this is simple. Car engines, truck engines, ship engines, and generators all take air from the environment around them. But when a submarine is deep underwater, it is surrounded by water. There is no free air around the engine to breathe. So when the submarine is deep below the surface, it cannot simply run its diesel engine the way a surface ship does. This is why batteries are so important. When submerged, The submarine uses battery power to move. This makes it quieter, more discreet, and less dependent on outside air. But batteries are not unlimited. After some time, the stored energy begins to decrease. And when the batteries run low, the submarine needs to recharge them. To recharge the batteries, the submarine uses the diesel engine and generator. But for the diesel engine to run, the submarine needs air. So the submarine must rise closer to the surface. It does not always need to fully surface. In many cases, it only needs to reach the proper depth and raise a snorkel mast above the water. This snorkel brings outside air down to the engine. When the engine has both air and fuel, it can run again. The engine drives the generator. The generator creates electricity, and that electricity flows back into the batteries. In this way, the submarine can recharge without fully surfacing. But this action has a disadvantage. When the submarine comes close to the surface and raises a snorkel, it is no longer as hidden as it is in deep water. Even if only a small part is exposed above the sea, it can still create signs. It may create a wake. It may create noise. It may create a small change on the surface. So for a military submarine, snorkeling to recharge is a moment that must be handled carefully. When running on batteries deep underwater, the submarine is quieter. When it must rise closer to the surface to recharge, it becomes easier to notice. That is the trade-off of a diesel-electric submarine. It can be very quiet when running on battery power, but it needs diesel fuel. It needs battery charging, and it needs air to run the diesel engine. So during a long mission, the submarine must manage energy very carefully. It cannot waste battery power. It cannot rise near the surface carelessly. It cannot recharge anywhere without considering the risk. Everything must be planned. The submarine needs enough electricity to move, enough fuel to generate that electricity, enough time to recharge, and enough stealth to continue the mission. Inside a submarine, energy is not just a technical issue. It directly affects how the vessel operates, how it hides, and how it keeps moving. When a diesel-electric submarine truly needs more fuel, it is usually refueled at a port, a base, or a suitable maintenance facility. At first glance, this may look similar to fueling a large surface vessel, but in reality, it is not as simple as connecting a hose and pumping fuel in. A submarine is a sealed, compact, complex system that must be balanced very carefully. When fuel enters the vessel, the flow must be controlled. Storage compartments must be monitored. Valves, pipes, and pumps must operate correctly. Leaks must be prevented, and the balance of the entire hull must be maintained. Because a submarine does not only float on the surface, it must dive, rise, hold depth, and operate under high pressure. If fuel distribution is not controlled properly, it can affect weight and balance inside the vessel. That is why refueling a diesel-electric submarine is part of a larger logistics and maintenance process. The submarine arrives at port. Its systems are checked. The fuel hose is connected in a controlled and safe way. Fuel flows into the storage compartments. Valves and pumps control the flow. Then the system is checked again. When everything is stable, the hose is disconnected. The submarine is ready to leave port and continue its mission. From the outside, it may only look like a submarine sitting beside a pier. But inside, many systems are being controlled at the same time. Each storage section must remain stable. Each pipe must be safe. Each valve must work properly. And the entire vessel must be prepared for something far more demanding. Returning to the ocean, diving below the surface, and operating under pressure. However, for a military submarine, refueling is not the only need. A submarine that must operate underwater for a long time needs many other things. It needs food. It needs water. It needs clean air. It needs spare parts. It needs maintenance supplies. It needs filters. It needs support equipment. It needs everything that allows humans to live and machinery to keep running inside a sealed space. So in many cases, supporting a submarine is not only about adding fuel, it is about replenishing everything that allows the vessel to continue its mission. A submarine may still have fuel, but if it lacks food, spare parts, replacement components, or life support materials, it cannot remain at sea for long. The ocean is not an easy place to stop and repair problems. Every supply item matters. Every spare part can help the vessel continue safely. A submarine is like a small closed city under the sea. It must carry many things with it. Every storage compartment has limits. Every meter of space is valuable. Food must be packed efficiently. Spare parts must be organized carefully. Equipment must be controlled. Air must be circulated. Water must be processed. All systems must work together in a space much smaller than a surface ship. This is why submarine logistics are more complex than they appear from the outside. When we see a submarine receiving supplies, it does not only mean it's receiving more fuel. It is receiving more ability to live and operate beneath the ocean. Food keeps the crew healthy. Clean water supports life and technical needs. Spare parts make repairs possible. Filters help maintain the internal environment. And all of these are just as important as fuel. Now let us move to the nuclear-powered submarine. This is a very different type of submarine. It does not need to use diesel engines to recharge batteries in the same way as a diesel-electric submarine. It also does not need to frequently rise near the surface to bring in air for a diesel engine. Its main power source is a nuclear reactor. This reactor produces heat for a very long time. That heat is transferred through protected systems. Then the heat is used to produce steam. The steam spins turbines. The turbines produce mechanical power and electricity. This energy feeds the propulsion system, the electrical system, life support systems, and many other systems inside the submarine. The key difference is that a nuclear submarine does not follow the same charging cycle as a diesel-electric submarine. It can maintain a strong and stable energy source for a much longer time. It is important to understand that a nuclear reactor is not like a normal fuel tank. It is not something that is refilled after every trip. Nuclear fuel can last for a very long time, depending on the design of the submarine. Because of that, nuclear-powered submarines can operate underwater much longer than diesel-electric submarines. They do not need to surface or snorkel to recharge batteries in the same cycle as diesel-powered vessels. They can maintain power for long periods, drive propulsion, generate electricity, process water, manage air systems, and operate many onboard systems at once. That is why nuclear submarines are often used for long-range missions that require extended underwater endurance. They are not limited by the need to bring air to a diesel engine. They do not need to raise a snorkel to recharge batteries. They can stay deeper, longer, and maintain more stable operation over time. But this does not mean nuclear submarines never need support. They still need maintenance. They still need inspection. They still need repairs. They still need equipment replacement. They still need supplies for the crew. And during major maintenance periods, important systems must be carefully inspected at proper facilities. For nuclear submarines, refueling is not like pumping diesel into a tank. It is a much larger and more complex process, connected to specialized maintenance and dedicated facilities. For this video, we only need to understand the general idea. Diesel-electric submarines need diesel fuel and more frequent battery charging. Nuclear submarines have a much longer-lasting energy source, but they still need maintenance and logistics. No vessel, no matter how advanced, can remain completely separated from support forever. For nuclear submarines, the biggest limit is not always fuel. Many times, the real limits are humans and supplies. The crew needs food. They need clean water. They need breathable air. They need a stable living environment. They need safe equipment. They need supplies to repair problems that appear during operations. A reactor may provide power for a very long time, but the people inside still need basic conditions to live and work. So even if a nuclear submarine can travel far and stay submerged for a long time, it still cannot be separated from logistics forever. It must return to base or receive support when needed. During a long mission, power is only one part of the story. The rest is life, safety, health, maintenance, and the ability to keep every internal system working. Now look at the life support system inside the submarine. The air inside cannot simply be used forever without treatment. People breathe in oxygen and breathe out carbon dioxide. If waste gases are not removed, the air becomes dangerous. So the submarine needs air circulation and filtration systems. Air is moved through processing units. Unwanted components are reduced. Oxygen is maintained at a suitable level. Clean air is returned to the internal compartments. This process happens continuously. Not once, not a few times, but throughout the entire time the submarine operates underwater. Inside a sealed submarine, air is not just something to breathe. It is a life-critical system. If the air system has a problem, the entire mission can be affected. Water is also extremely important. A submarine is surrounded by seawater. But humans cannot drink seawater directly. So the submarine needs systems to process water. Seawater can be treated or desalinated to produce usable water. Clean water is then stored and distributed to the areas that need it. It supports daily life, technical systems, and many other needs inside the vessel. This shows that power is only one part of the problem. To live underwater for a long time, a submarine must turn an environment that is hostile to humans into a space that can support life. Outside, there is saltwater, pressure, and darkness. Inside, there must be breathable air, usable water, stable temperature, and safe operating systems. Food is another real limit. No matter how powerful the submarine is, the crew still needs to eat. Food storage inside a submarine is limited. Everything must be packed carefully, preserved properly, and used wisely. During a long mission, the amount of food carried directly affects how long the submarine can operate away from support. In addition to food, the submarine must carry spare parts. A filter may need replacement. A device may need repair. A system may need maintenance. Without the right supplies, a small fault can become a serious problem. That is why submarines have storage areas for technical supplies and maintenance materials. These areas may not look as dramatic as engines or reactors, but they are extremely important. Because in the deep sea, one filter, one small part, or one replacement unit can help keep the entire system safe. When we put all of this together, we can see that a submarine is not simply a vehicle powered by fuel. It is a closed system. Energy keeps the submarine moving. Electricity keeps equipment operating. Air keeps the crew breathing. Water supports daily life. Food keeps the crew alive for many days. Spare parts allow the submarine to repair and maintain itself. All of these elements are connected. If there is fuel but no clean air, the submarine cannot continue. If there is power but no water or food, the mission cannot last. If there is a powerful reactor but the equipment is not maintained, safety can be affected. A submarine is not strong only because it has a powerful engine. It is strong because every system inside is designed to work together inside a sealed environment. This is why, when we talk about how military submarines refuel, we should not only imagine a fuel hose pumping diesel. For a diesel-electric submarine, refueling means adding diesel, checking systems, charging batteries, and preparing for the next operating cycle. For a nuclear submarine, the power source can last much longer, but maintenance and resupply are still required. Both types of submarines need a logistics network behind them. No submarine operates alone forever. It may dive deep, travel far, and hide in the ocean, but it is still a system operated by humans. And every human-operated system needs energy, supplies, and maintenance. The difference is how each type of submarine gets energy, stores energy, and maintains that energy during a mission. The difference is in how each type sustains power. A diesel-electric submarine has a clearer cycle. It uses diesel to create electricity. It uses batteries to move quietly underwater. When the batteries run low, they must be recharged. When fuel runs low, it must be refueled. A nuclear submarine is different. It has a long-lasting heat source from the reactor. It can produce energy for a very long time without refueling as often as a diesel-electric submarine. But it still needs people, maintenance, water, food, and supplies. One type is more limited by batteries and diesel fuel. The other has a major advantage in energy endurance, but it is still limited by logistics and human needs. So when we say a nuclear submarine does not need frequent refueling, it does not mean it needs no support. It simply depends on support in a different way. Visually, the difference is clear. A diesel-electric submarine may need to come close to the surface. A snorkel mast appears above the waves. The diesel engine runs to recharge the batteries. Electricity flows back